Okay, when we look at problems A, B, and C in 248, we're talking about different ways to code or simplify algebraic expressions. So in the first one, we have a model that looks like this, where we have something that looks like that, and then on the left side, we have this. So the idea here is to think about pairs or opposites. And when we just discussed, and we discussed it on Friday, when we have opposites, um, those equal zero. So those make zero. So when we're looking at something like this, we would probably want to consider taking out our opposites first and then comparing each expression. So we can I always put them together so that way I know what they are. You'll see on your in your book they've used circles, and so if you had an actual physical sheet, that would work also. So on both sides, I'm going to look to see if I have opposites, and then I'm going to kind of divide them off. And so I can see here also on the right I have these, but then I'm left with these two. So you can either leave them that way, or you can actually physically just remove them off the mat, which is usually what I do just to save on confusion. So now I'm able to see what I physically, so which equation would be greater? Well, I have a value of a positive 1 in my left, and I have a value of a negative 2 in my right. So thinking about on the number line, which is greater, our left side would be greater. And so we call this making zeros. So that would be the strategy for A. Now for B, we have something that looks like this. And then you notice in the book there's two arrows that move these up. Think about why they would do that. Well, this is in the negative space, and this is a negative 1. This is a negative space, this is in a negative 1. So these are actually a positive 2. So we call this the flip, where we would actually take those tiles, you would move them up to the appropriate signage or value place, and then your tiles you would flip over. Mine don't flip. So then you flip it from the negative region to the positive, or you can actually go positive to negative either also. Then you can look at which side is greater. And again, you can take out your zeros. So we have a 0 set here, and we have a 0 set here. So I'm going to take those off. Now I have a positive 1 in the left side and a negative 1 in the right side. So my left side will be greater. So for B, the strategy or the coding that we used, we call it the flipped tile. For C, we have something that looks like this. And this one, then when we look at the simplified mat of that, because that's how it's put together on our lab sheet today. So this was our original, and we look at our simplified. Well, for the simplified way, we're going to try to figure out if we look at our lab sheet from today. So it started like the way we have it mapped out, but then it's just left with these. So this is the simplified mat. And so that's what you also see in your ebook. So how do we get there? Well, what they have left are just these tiles. So what did they do? Well, these are both, this is an x1 and this is an x1, so they have an equal value. So they took off the equal values. So then still you could look at this and say, well, I have a positive 1, a negative 1, and a negative 1. So that would be your value for this side. Here I have a positive 1, a positive 1, a negative 1, and a negative 1. So you could do a couple of things here. You could either find your zeros and take them off by finding your zeros, or you could take off your identicals also. Well, we have a pair here and a pair here, or we have a 1 and a 1 here. We have two negatives here. We still end up with the same result. So we have nothing left in our left side, but we have 1 left in our right. So our right side would be the greater expression. This one is called removing equal parts.